Yeah. Okay, well, welcome everybody. This is a talk about C# and audio programming. It's a real privilege to be speaking on this topic that maybe it's a little bit of a niche subject, but I certainly find it very interesting. Just to give you a little idea of who I am, my name's Mark Heath. I'm a Pluralsight author. I've created over 20 courses on Pluralsight, including 3 about audio, which hardly anybody watches. Most of my courses are about Azure, microservices, that kind of thing, because my day job, I'm building digital evidence management systems for the criminal justice system in Azure, which does get me an opportunity to do a little bit of audio programming, which I'll talk about later. But probably the most relevant thing for this talk is that I'm the creator of an open source audio library for .NET called NAudio. And so actually this talk is going to be a bit of a story to tell you how I came to create NAudio, but also I'll be diving into some of the technical details of what it's actually like to try and write audio code in .NET and what you can achieve and what some of the big challenges are. So my story actually starts in the last millennium. How many of you are old enough that your career began in the last millennium? And back in the day, we used a variety of languages. So I was using C and C++ for some things, and I was using Python and Visual Basic 6 for other things. And you may know that the difference between these types of language is that C and C++, they're compiled languages. Your code gets compiled directly into machine code. Whereas Python, Visual Basic 6, those languages are interpreted. Your code is actually being interpreted at runtime. And the general understanding was, if you wanted to do anything that was fast, you had to be in the world of C or C++. And with audio, you typically do want your code to run fast because it's often real time. Also, if you wanted to do anything low level, so you wanted to call operating system APIs, or if you wanted to interact with devices like a sound card. I've got a little sound card here, I've got a little MIDI keyboard as well, which we'll hopefully use later if we have time. You wanted to be in the world of C. However, it came at a cost, and that was complexity. It was very easy to shoot yourself in the foot. And so we try and do as much as we could in the interpreted world, because even though maybe they were thought of as slow, the OS was abstracted away, it was just easier to work with, and you could do what we called rapid application development. But then about the end of the 90s, Java actually came across my radar. And the interesting thing about Java is it didn't fit neatly into either of these two worlds. You may know that Java compiles, you do compile your code, but you compile it into bytecode, which is kind of machine code for an imaginary virtual machine, and then the Java virtual machine runs that. It makes use of what's called a JIT compiler, which is very fast and efficient to actually convert that bytecode into machine code at runtime. And it had an innovative approach to memory management called the garbage collector, which is going to be very relevant for .NET. And in my mind, and I think actually in a lot of people's minds, Java was still in the slow category because it wasn't in the compiled world. But then I stumbled across this project in the late 90s. It was called Java Layer. And what these guys had done, they had implemented a full MP3 decoder in Java. And of course, in the late 90s, MP3s were all the rage. We were all ripping our CD collection to MP3 so we could play it in Winamp. And this surprised me. I wasn't expecting this kind of thing to be done in Java. And not only had they done that, but they had implemented a player. So it could do it in real time, decode your MP3s to WAV and play it through the sound card. And so that blew my mind. And it was actually the first thing that I converted to .NET. It's open source. It's actually been rewritten twice since I originally did it. However, not long after that, .NET came along. And I was very interested in .NET because I was primarily a Windows programmer. And Java wasn't really very Windows friendly. If you made a Java app, it didn't even look like a Windows application. You had this .jar file, and people on Windows were like, how do I run a jar? So .NET was very interesting to me. And one of Microsoft's innovations was they had multiple languages. So they had VB.NET, which was similar to VB, but all the VB6 programmers hated it because it wasn't actually the same. They had Visual J#, which was actually Java for .NET. Did anybody have the misfortune of using that? One other person. Not many people use that. Microsoft got into legal trouble with it. But that was actually the way I initially ported that Java Layer project to .NET. C#, which of course, as we all know, is now the flagship language. And there was also a thing called managed C++, where the idea was you could take the best of both worlds. You could have the best of managed code, .NET, and native code, although I found it incredibly confusing to use, kind of gave up on it. And when .NET came out in beta, I filled in my details so it could be posted to me, the beta, on 4 CDs, because my modem wasn't fast enough to download the whole thing. And the first thing I looked for was, where is the audio support in .NET? I read all of the APIs. I'm like, there must be some audio, because Java can do it. Where's the .NET? And there was nothing, or virtually nothing. It was useless. And so that spawned this idea, why don't I create my own audio library? And surely Microsoft will, in the next version of .NET, they'll fill it in, and my audio library will then become obsolete. And so I started working my evenings and spare time on making NAudio, I called it. Everything in .NET land was called N something, because everything in Java world was J something. And I had 2 goals. One was I wanted to make it possible to call any Windows audio API. So anything that Windows could do with audio, I wanted you to be able to do it if you were a .NET programmer. And I also wanted to make a collection of building blocks that were commonly used things that people making audio applications would be able to use to build their own audio applications. Because really, I didn't want to make a library. I wanted to make my own audio apps. And so I worked away on this in a while, and I got a few initial things working. I got audio playback and recording. I was able to read and write WAV files and MIDI files. If any of you are into music production, you'll know what a MIDI file is. And also, I really wanted to be able to play MP3, because that was the most important audio file format at the time. But then a few years later, I got a job at a company called NICE, where I'm still working. It's actually almost 20 years, so it is a fairly nice company to work for. But they were about to embark on a brand new project. They were going to build an incident reconstruction application. So if something bad has happened and you want to piece together all of the 999 recordings, all of the police radio, all of the CCTV cameras, you wanted to put it together in a timeline and play back what had happened for an investigation. And this was all going to be done in .NET, and I realised this was actually the perfect use case for NAudio, because although in my mind NAudio was all about writing music apps, because that's kind of what I'm interested in, this is a voice application, but actually many of the things that it needed are the same kind of things that I was needing to make music applications. So I volunteered and I said, let me be the one who writes the code, the audio mixing engine for this application. So I implemented things like variable speed playback, some basic effects like automatic gain control. So if someone's talking too quietly, you amplify them. I had to deal with things like live streaming, so that you're playing audio while it's still being downloaded, and sometimes you have to buffer and stop. We also had to do audio and video synchronization. I don't know if anyone's ever tried to synchronize videos. It's really horrible, because if you've got 2 video players and you say jump to this time, they won't actually jump to the time you've asked. They'll go somewhere roughly close. And now they're out of sync and you've got to try and get back in. Whereas with audio, it's actually a little bit easier. If you've got a few bits of audio, you don't individually play each bit of audio. What you do is you mix it together before you give it to the sound card. And that means that you can always stay in sync, and wherever you jump to, you will never drift out of sync from the previous times you played it. And this thing had a mixing engine to do just that. It was a 32-bit floating point mixing engine. Again, any of you who are familiar with audio production will know that you typically use 32-bit or use floating point samples to do audio manipulation. You want to get out of the integer world. But the sample rate was a lot lower than you might expect if you know anything about music production. Sample rate was 16 kilohertz. And that's because for voice applications, the human voice is perfectly intelligible at quite low sample rates. So I worked away on this. I also had to do things like visualization of waveforms. So some of that is also open source on the internet, of drawing waveforms and doing spectrum analysis, that kind of thing. And probably the most interesting thing that this application was used for was there was a big incident where a plane took off and hit a flock of gulls. and the pilot made the decision that he couldn't get back to the airport and he needed to land on the river. And they did a big investigation to piece together everything that had been said on air traffic control. And I believe this application was used for them to listen back and reconstruct what happened. And it's been turned into a movie, as you can see. Now, to rewind a little bit, how many of you have read your employment contract? Almost. Well done, a few of you. Quite boring. Probably somewhere in your contract it says any code that you write while you're employed by us belongs to the company. And so I realised this could be a problem. If I just took all my NAudio code that I've been doing in my spare time and just stuck it in a commercial code base, I could get into a weird situation. So I thought, right, NAudio, at this point, although in my mind it was an open source project, what that meant was I had a page on SourceForge. Anyone remember SourceForge? And I couldn't work out how to use their version control, so I just occasionally put a zip file with a DLL in it up on there. And I thought NAudio needs to be a proper open source project. And fortunately, Microsoft had just decided they were going to make their own open source hosting website called Codeplex. Anyone remember Codeplex? And this was much better because it was an open source site that Windows programmers actually knew how to use. So that was brilliant. I got my code on Codeplex, and I also needed to choose a license. And Microsoft, as they want to do, decided that none of the existing open source licenses were any good, and they had to invent their own. So they invented their own Microsoft licenses, and I chose the Microsoft Public license, which is a commercial-friendly open source license. So it meant that the NAudio code, you can use it in a closed source application if you need to. I've actually backed out of that now, and not backed out of it being used in closed source, but I'm using MIT because nobody knows what those Microsoft licenses actually mean. So let's shift gears now, and let's talk a little bit about some of the challenges that I encountered when trying to implement audio code in .NET. And the first big challenge is p-invoke. I had to do a lot of what's called platform invoke to call all the Windows APIs. There's hundreds of Windows APIs. And the way you do this is basically you get the C++ header definitions of every method that you want to convert. And then you have to work out how to convert it into a signature. So, for example, in the Windows Audio API, there's a method called waveInGetDevCaps. And that is a method to ask your recording device, what capabilities have you got? And this is in the WinMM DLL, which is part of Windows. So you decorate it with a DLL import attribute. You say what DLL it's in. So you can do this for any DLL. It doesn't have to be part of Windows. And you mark your method as static extern. And then you have to go through every parameter of that method and work out what the equivalent .NET type would be. And that actually can be quite challenging because the C++ programmers love their hash defines. And so you have to often follow a chain of hash defines to work out what actually is a W param or a D word or whatever. And so after a while, you get to learn a D word means it's 4 bytes, so I can use an int. A word is 2 bytes, so I can use a short. One of the mistakes I actually made was when I was doing this, it was in the world of 32-bit operating systems. And so a pointer and a D word were the same size. And so often I just used int in the method signatures. However, when we went to 64-bit, pointers are no longer 32 bits long, they're 64. So I had to use int pointer everywhere and fix that all up. So you map all of these parameter types, but also C++ programmers love their structs. Loads of methods have got structures, and so this method has an out parameter of waveInCaps too. So in other words, when I call this method, I'm going to give it a memory location, and this non.NET code is going to write into that memory location. So we need to define the layout, and so you have to do all of this for every structure as well. It actually doesn't have to be a C# struct, it can be a class, it works just as well. But you have to mark it with the struct layout, and you have to say that it's layout kind sequential. And what that's basically telling .NET is you don't have freedom about where you stick these things in memory, can't move it around to be more efficient because something else is expecting the memory layout to be exactly like this. Another thing that you'll know if you've done any C or C++ programming is that there are many ways to pass strings around. You can pass pointers to a string, or your structure can just have an array of memory that may or may not be null terminated, and it might be single byte per character, or it might be wide characters. And so wherever you have a string, you use this marshal as to say, what kind of string marshalling am I making use of? So I had to do a lot of this, many hours, many getting it wrong and crashing my probably Windows XP or whatever it was back then I was using. The next challenge I want to talk about, though, is garbage collection. And in one sense, the garbage collector in .NET is really great. It's actually one of the selling points of the language. I've mostly got nothing bad to say about it. It uses a very intelligent algorithm called the generational mark and sweep algorithm. And basically what happens in .NET with garbage collection is your program is running away and running along as normal, and at some point, not under your control, .NET will say, you're using too much memory, I'm going to do a garbage collection. And at that point, every single one of your threads stops. Nothing in your application at all is running. And then it does a bit of a look around. It sees, of all the memory that's been allocated, is any of it not in use anymore? And it frees that up. It doesn't necessarily have to free all of it up. Sometimes it just does a little bit for performance reasons. And then it's also allowed to move stuff around. So after it's freed up some memory, if it wants to, it can do a bit like a defrag and just sort of move everything together. And this is, like I say, on the whole, brilliant, works really well, doesn't cause any problems. But for audio programming, it causes two very big problems, or it can cause two big problems. The first problem is that any time you're pausing, it interferes with your ability to write low latency code. And so what do I mean by low latency? Well, imagine I've got my MIDI keyboard and I'm making a synthesizer. And so I want, when I press my key on the keyboard, I want to immediately hear the sound. I don't want to hear the sound half a second later, because that'd be just unplayable. And so often you're talking about, say, 10 milliseconds, sometimes less, is what you would like. And so the way you achieve this is when you're playing audio, you give the sound card 10 milliseconds of audio, and while it's playing that 10 milliseconds of audio, you're making the next 10 milliseconds of audio. And so as long as you've got your next 10 milliseconds ready, everything is fine. If you miss your chance to give that next 10 milliseconds, what you'll hear in the audio is crackles and pops. And that doesn't sound good. You certainly don't want that in a live context. And so there is a big risk that if the garbage collector jumps in the middle of your 10 milliseconds and steals some of it, hopefully not all of it, but you now run the risk of a dropout. So that's the first big problem. The second problem is the compaction problem. Because we've got this mixture of .NET code and native code, if I've given native code a pointer to a byte array and say, please, sound card, write the audio that you're recording into this byte array, and then the garbage collector just moves it somewhere else, you will crash your computer, which I did many times when I was initially writing all of this. So what are the solutions? Well, there's no solution to the garbage collector running other than writing allocation-free code. So not actually giving the garbage collector anything that it needs to do. And in one sense, it's not that hard to do with audio programming, because you can pre-allocate your buffers. So I can make two 10-millisecond buffers of audio, and I can give one to the sound card while I'm filling the other, and when the sound card's finished that one, I just start filling that one up again, rather than keeping on allocating new memory. Now, unfortunately, your audio code might not be the only code. If you're running a Windows Forms or WPF application, then that's allocating memory all over the place, and the garbage collector will run at some point. You can also pin objects. So you can tell the garbage collector, you're not allowed to move this, or you can say, actually, I'm not going to ask .NET for this memory, I'm going to ask the operating system. And so the operating system gives me some memory, and then that's not going to move anywhere. So just to show you how you do that, in C# there are two very unused keywords, or rarely used keywords, unsafe and fixed. I don't know if any of you have used them. The unsafe keyword, I think, does a very good job of scaring most programmers off using it. But if you mark your method as unsafe, then you can get a C-style pointer to a byte array and inside what's called a fixed block. And in that fixed block, it is guaranteed that the garbage collector is not going to move stuff around in memory. However, you can't always be in a fixed block. So sometimes you need to use the GC handle. So you can say GC handle alloc, and you tell it, give me a pinned handle to this object, and then you can get the pointer to it, and then you can give that to the unmanaged code, and you can free the handle when you're done with it. If you want to use native memory, there is in the Marshall classes, a number of useful things, including alloc h global. So you can just say, operating system, give me a megabyte of memory, and then you can get a pointer to it. But now you've got the problem that, like, if I've got a C# structure, how do I copy the contents of that structure to a native pointer, or vice versa? So you have Marshall structure to pointer, and the opposite way round, Marshall pointer to structure, to copy memory backwards and forwards. One of the other big challenges I faced was making a decision between porting algorithms. And so by algorithms, I'm talking about things like digital signal processing, maybe effects, resampling, or fast Fourier transforms, that kind of thing. Or just doing interop wrappers to native DLLs that have already got them. And actually, codecs is, of course, one of the big examples here where you might have to make this decision. And both have got advantages and disadvantages. So one of the big advantages of interop to native code, if I've got a DLL that's got a codec implementation, it's going to be a lot less work for me to just write pinvoke wrappers to call that DLL than try to port the entire codec into C#. In theory, I'm not sure this necessarily has to be true, but in theory it ought to run faster because that DLL has been well optimized and compiled with all the necessary flags to run as fast as possible. It's also much easier to keep up to date. So if you've ever ported an algorithm from one language to another, and then the next week it's like, surprise, there's a new version of the original code base. Now you've got to go back and do all the diffs and work out what I have to change in my ported version. Whereas with pinvoke, hopefully it's just a case of dropping in a new version of the DLL. Also, if any of you have done porting code between one language to another, it's very easy to make small mistakes. And I found this particularly with bit manipulation. Like, there's often really subtle differences between languages where the same syntax doesn't actually do exactly the same thing between the two languages. However, the big downside to just saying, well, I'll just do pinvoke around a native library is that I now can't run everywhere. I can only run on the systems where I've got that DLL available. And so the advantage of porting to managed code is, of course, that it's portable and that you can run in sandboxed environments. Now, who remembers Silverlight? I loved Silverlight and I wanted to do audio in it, but I couldn't use anything that had pinvoke in it because it was a sandbox. It wouldn't let you do that. And so that made me start to want to try and convert some algorithms to C#. But also, I've never used it, but Unity is a C# programming language, runs on different platforms, and people were like, oh, can I use NAudio? And the answer is, well, yes, you can use NAudio, but you can only use the bits that aren't calling Windows APIs because they're just not there on your target operating system. One of the examples of this was resampling. So resampling, you may know that with audio, every audio file has a sample rate, and sometimes the sample rate of your file isn't the sample rate of the sound card, and so you need to resample the audio so that you can play it, and also so you can mix it together with other files. And at first I thought, oh, I could probably do this myself, how hard could it be? Actually, it turns out that unless you've got some quite good mathematical and digital signal processing knowledge, the resampler you implement yourself will actually sound terrible. So I then started finding things I could wrap, and Windows has no fewer than 3 APIs, all horrible to wrap. And I ended up wrapping all three of these because different versions of Windows had different ones. If you're on a server OS or if you're on a Windows XP or something, you could only access one of these three. But even having done all three of those, it still wasn't universally available everywhere that I wanted to use it. And so I thought, well, maybe I can find an open source resampler and port it to C#. And one of the problems you run into is virtually all open source audio code is licensed to GPL or LGPL, which is not compatible with a closed source friendly license. But eventually I found a company called Kokos who make the Reaper digital audio workstation, which is the one I use. They had a resampler whose license looked compatible, so I reached out to them and they were okay with me porting that. So NAudio has now got a fully managed audio resampler. Okay, let me just check how we're doing for time. I think we're doing okay. Windows APIs. Now, Windows has got a number of ways of providing audio functionality, and I've ended up writing wrappers pretty much for all of them. I'm not going to talk about them all, but just briefly, the first one, and the one that's been around the longest, is WinMM. And this came out in 1991. It's still supported, fully supported in Windows, the multimedia API. And the probably most well-known APIs in this are wave in and wave out, which allow you to record audio and play audio, but there's a bunch of other things for dealing with codecs and dealing with your mixer and that kind of stuff. Unfortunately, these have, I'd call it high latency. I've never really got below 50 milliseconds of latency with these APIs. One of the things that this API lets you do is when the sound card is finished playing audio, it can tell you that it's finished playing audio so that you need, so that you can provide the next buffer of sound. And it gives you a choice of how it tells you. And one of the choices was it can call a function. I thought, that's perfect. I'll give it the address of a function, and it can call my function when it needs more audio. First of all, I realized you need to pin that function, because if you don't, it will move around and your app will crash. But secondly, I found that you got all kinds of horrible deadlocks if you did the wrong thing in a callback from native code into managed code. So the next option was you can get it to post a Windows message to a Windows message pump. And that works really well, apart from it annoyed some users of NAudio because it meant you had to take a dependency on Windows Forms. You had to kind of have this fake hidden window somewhere that was receiving messages. And so the third option, which I wish I'd done from the beginning, was you can just have a mutex and you can say, it will set the mutex and you wait on it and then you provide the audio. And so that's the way I recommend you use it. It's slightly weirdly named class in NAudio called wave out event, but that means you're using the mutex for the callbacks. So a mutex is an operating system construct that basically says, I want to be able to block any other process from doing anything until I say I'm ready. So one process can, if you like, lock the mutex, and another process can say, I'm waiting for that mutex. And when the first one says I'm finished, then it signals the other one. So it's a way of writing thread-safe code, but it can also be used for inter-process communications. Yes, it's a lock. Essentially, a lock is doing that behind the scenes. There's a lot of different types. There's semaphores and so on. I don't know what the lock's using. Actually, there's a lot of locking in NAudio because typically you have an audio thread and you have a GUI thread. And you've got to be very careful. Wasapi is an example of an API that is COM-based. And with COM objects, sometimes you can't call them on a different thread from the thread you created them on. And so there's a number of hoops I had to jump through in NAudio to try and make it so that you created the COM object on the right thread to use it. So Wasapi, in 2007, Microsoft decided they were going to break everything and change everything with Windows Vista. And one of the things they did was they completely rewrote the Windows audio system substack. And so Wasapi is Windows Audio Subsystem API. And actually, in many ways, it's a much better API than the old one. It gave you a choice of exclusive or shared mode. So exclusive means I'm the only one that's allowed to talk to the sound card, whereas shared mode is you're sharing it with other applications. And so in exclusive mode, theoretically, you can get much lower latency. One of the real annoyances was in its initial implementation, you had no option but to give it audio in the sample rate that it was already playing at. So if you had just played a CD, you had to give it 44.1 kilohertz. If you just played a DVD, you had to give it 48 kilohertz. And that was part of the reason why I needed a resampler, so that I could convert your audio to what Wasapi wanted it in. They have actually changed that now. So you can tell Wasapi, I'm giving you audio that's 16 kilohertz integer, and you just convert it for me, which is brilliant. So that's now in NAudio. Another great feature that Wasapi had is loopback capture. So you could finally record the sound that your operating system is playing. You can actually, with Wasapi, although I've not got this into NAudio yet because it would be a breaking change to the API, you can actually record just the output from a single application now on Windows. And so actually, Wasapi is probably the best thing to use now. I would say I recommend it if you're doing new applications, you want to play audio on Windows, use Wasapi. It is better than WinMM, finally. But then in 2016, Microsoft introduced another API as part of the Universal Windows application. This was called Audio Graph. And I was very excited about this one because this was the first one that was callable immediately from .NET. I didn't have to do any interop wrappers for it. You could call all of the APIs. And it was actually a really nicely designed API. It was a graph-based API. So you had the concept of input nodes, output nodes, and submix nodes. And so you built together a graph, which we'll talk about in a minute. And so I thought, finally, this is it. NAudio, or large parts of NAudio, don't need to exist anymore because Microsoft have made what we need. However, it has one gigantic gaping hole, and that is you cannot make a node that transforms audio or generates audio unless you make a completely separate project that's a COM object, and you do it in that project, and you have to use lots of unsafe code and fixed code to do that. You register the COM object in Windows, and then your application loads that. And so it's very frustrating, but I think hardly anybody, I don't know anyone who uses that API, apart from maybe very simple applications. So the best Windows audio API is not made by Microsoft. It's, have any of you heard of ASIO? Any of you who do music production will know about this. This was made by Steinberg in 1997, and basically it's ideal for low latency. That's what it's intended for, people who are doing recording and playback. So if you bought a nice sound card, something like external USB one like I've got here, that will have ASIO drivers. And one of the really nice things about the way it works is it uses this buffer swap for record and playback. So Windows thinks of recording and playback as two completely separate things, whereas ASIO, you do both together. And so when you get the callback, it's give me more audio to play, and here's what I just recorded. And the great thing about that from a music production perspective is that you want to perfectly synchronize. If I'm listening to the backing track and playing my guitar, I want what's recorded to be perfectly synchronized to what I was hearing. And ASIO makes that much simpler. And ASIO is also a good example of the benefits of being an open source project, because I don't think I would have known enough to do the pinvoke wrappers for ASIO, but somebody contributed a really great set of ASIO wrappers, and it basically means now anyone who's doing .NET can use NAudio for using ASIO and doing some quite low-level, faster audio programming. Okay, the next challenge I want to talk about is designing audio APIs. What makes a good audio API? And I've kind of hinted at this already when we talked about audio graph. In audio, it's very common for you to construct what you might call a signal chain. So guitarists love this. They plug their guitar into a pedal, and that goes into another pedal, and so on, all the way to the amplifier. And basically, NAudio copies this idea. You're building up a a graph or a signal chain of audio. And of course, it can be a bit more complicated than that. You might have multiple things producing sound. So you might have the microphone is recording and you're playing a file. And you might be transforming those sounds in different ways. I might put a reverb effect on the microphone, but I might also want to do visualization. As the audio is coming through, I might want to show a volume meter or a waveform. And then I want to mix the audio together, which would mean I need to get it to the same sample rate if it wasn't already. And then I might actually send it to multiple places. I might play it out the sound card and save it to a file. And so NAudio has got a couple of interfaces that support this. The two most important ones and the lowest level are the wave provider and the sample provider. The wave provider basically is, all it's saying is I'm something that can give you audio. And so it has a wave format property that tells you this is the sample rate, is it mono or stereo, how many bits is it, might even be compressed. And then a read method, which if any of you have used streams, will look very familiar. You're saying I want to read some audio into my buffer and I want this many bytes, and it will tell me how many bytes of audio it read. And this is great, it's very flexible, but if you're writing audio code, it's very annoying because what you really want is samples. You want access to the individual samples. You don't want bytes. So there's also iSample Provider, which is exactly the same thing, but you're getting floating point samples. And so in NAudio, there's lots of helper methods that try to get you to sample provider as quickly as possible. So once you're at sample provider, you can change the volume, you can mix things together, you can visualize, you can do fast Fourier transforms, whatever you want to do with the audio samples. However, going from byte array to float array is actually not as easy as you might think. Because if you declare a byte array and then try and cast it to a float array, that will not compile. So what do you do if you've got a byte array that has got your audio in, but you actually know that inside there are floating point samples? Well, one option is the unsafe and fixed keywords that I just talked about. So that will let you cast between, you put it in a fixed block, you can then cast between a byte array and a float array. However, that wasn't great for NAudio because then I would basically force unsafe code on everybody, and lots of coders are not comfortable working in that world. A couple of other options are just copy it. Okay, I've got a byte array, I'll have another float array, and I'll just copy stuff into the float array, and there are some helpers that will do that. Buffer.blockCopy will copy everything in a byte array into a float array if you want. But of course, it's an unnecessary copy. And so I was kind of stuck, and then the same guy actually that contributed the ASIO wrappers gave me this almost mad genius feature called the wave buffer. And what wave buffer does is it takes advantage of a capability in C# of dealing with unions. And in C++, a union is basically a structure that says at this memory location, there might be this, there might be that, or there might be something else. And because you need to be able to call unions or methods with unions in C#, the struct layout kind explicit lets you do that. So what I can do is I can say at memory address 4, there might be a byte array, there might be a float array, there might be a short array. And what that means you can do is you can write into one and read out of the other. And when I first saw this, I thought that is madness, that will never work. It works absolutely perfectly. It's worked for 20 years across every version of .NET. The only weird thing is don't try asking the float buffer what its size is because it's confused about what its size is. But you can write into one and read out of the other. So that gave us casting. However, if only there was a feature in .NET called span of t, wouldn't that be lovely? And of course, that came in .NET 3.1. So had NAudio been written many years later, I would have used span of byte and span of float. And span has got, for those of you who are not familiar with it, it's got a number of benefits. One benefit is a span can be backed by managed or unmanaged memory. It means you don't have to care whether you asked the operating system for the memory or you asked .NET, which is fantastic. Span also knows how long it is, so you don't need the length parameter anymore. And spans can be sliced, so you can just say, just show me this window, if you like, of the memory. So you don't need that offset parameter either. So it just makes everything a lot simpler. And of course, as I just mentioned, they can be cast. So you give me a span of bytes, I can say, actually, I know there's floating point numbers in there, so I will use memory_marshal.cast and turn my span of bytes into a span of floats, read in or out. Really super convenient. And I actually made a branch of NAudio that converted everything to span. It's in the GitHub repo, and it kind of got stalled, partly because the VB people complained that you can't use spans in VB.NET, which surprised me because I thought you could do anything that you can do in C#. But also, it's quite a big change to NAudio, and so I'd either need to support old and new methods or write lots of adapters or lots of documentation. So it's kind of parked, unfortunately. Some other great things that have happened, I call this recent. By recent, I mean things that have happened since NAudio began 20 years ago. So one of the greatest things was .NET Core coming along, now just .NET. Suddenly, NAudio becomes cross-platform. However, as I have to keep pointing out in GitHub issues, just because it's cross-platform doesn't mean that on Linux, Windows APIs will appear. So you can't use the bits of NAudio that call Windows APIs if you're not on Windows. But I love the focus on high performance that has gone into it. That's really important, obviously, for any audio applications that are real-time. There's also been a lot more low-level stuff added to C#. You can better support for function pointers, better control over the actual IL instructions that you compile, which is useful for some COM-based things. And there's even now code generation for pinvoke to make pinvoke much faster. Again, something probably if I was redoing NAudio, I would be looking to make use of. So can you use .NET for NAudio? Hopefully, I've persuaded you the answer is that yes, you can. It's not necessarily perfect, but there's an awful lot you can achieve in .NET. I've built the NAudio toolkit. I've got a fully managed MP3 decoder in .NET. All of this is open source. I even made an application that could transform your voice in real time over Skype, so it intercepted the audio and put silly robot effects on. Sadly, that doesn't work anymore because of a breaking API change. I made applications that converted MIDI drum grooves from one drum sampler to another. And I've actually used NAudio in a number of quite large commercial products for all kinds, particularly telephony related. And I know of a lot of companies that are using NAudio in telephony and radio related use cases. So there is a lot that can be done with .NET. Before we get onto a demo, because I've got a short demo for us at the end, I wanted to give a little status update on the NAudio project. And I think this is actually an issue that we're seeing a lot of in the open source world at the moment. And that is the fact that many of the open source projects that we know and use were just started by enthusiasts like me in their spare time, working when they're evenings, just having fun, making stuff and sharing it with the world. And essentially, you're just kind of offering your efforts for free. But over time, that was 20 years ago. Other things have happened in life. I've got children. My time for working on it in audio has become greatly limited. And so essentially what I find myself, I'm kind of maintaining NAudio. I'm usually answering people's questions almost every day. But in terms of adding new features to it or doing sort of big changes like converting to span of T, that's really not happening. And so I'd say it's no longer under active development. And so I am interested, actually, if anybody does want to join the project and got enthusiasm for it, maybe that's why you're here, I am open to new maintainers. But unfortunately, not a lot is happening in terms of new features of NAudio, partly because I'm not using it in my day job anymore. That helped a lot. When I was using it in my day job, it inspired me to add a lot of new features. OK, so I've got some links where you can find out more. Probably most relevant one is where NAudio is on GitHub. But I thought we'd end with a very short demo. So I'll just give you a moment to, if you did want to take a photo of that. Shouldn't be too hard to find on the internet anyway, just with a search. But we're going to jump into Visual Studio. And Don't worry that you can't see the code, because we're not really looking at the code. But this is a very simple application that if I start it up, so when I start this application up, it's going to let me choose which sound card I'm going to play sound out of. I'm going to choose my Focusrite device. And what it's going to do, it's going to scan for all MIDI devices. And these little keyboards are called MIDI devices. MIDI is the protocol that tells you what notes you're pressing. And it's going to listen out for notes being pressed on the keyboard. And then what it's going to do is, when it hears a note, it's going to use a software synthesizer, all written in C# to play the sound. And it's going to use a file format called sound font, which essentially takes recordings of real instruments and tries to map them to notes on the keyboard. So if I play some notes, as if this is working, we will see it is playing the sounds. I'm also printing out the MIDI note-on events, how hard I pressed each note. If I press these pads, those pads are sending MIDI on channel 10, which in MIDI means that's the drum channel. So it's playing drum sounds. And then the final thing is that, and I didn't actually write this, but somebody else wrote this, a MIDI sequencer. So a MIDI file essentially records what notes you hit on the keyboard at what times you hit them, and then you can then play that back. So the MIDI sequencer will then try to play back the same notes at the same times. So I've got a key here, and if I press this, it's going to load a MIDI file. It's going to sequence it, play it back through the sound font. And I think this would have actually blown my mind, this demo, when I first started NAudio. I didn't believe that .NET would be able to do something like this in real time. But maybe this won't be impressive to you, but this is going to play a MIDI file, if it works. Okay, so that is the end of my talk, and I'm happy to take any questions in the last few minutes.